Dear speech prosody community, welcome to our talk that we title Speech Rhythm in Ghanaian Languages, the Cases of Akan, Ewe and Ghanaian English. The authors are Natalie Boll-Avetisyan, Okyere Omane from the University of Potsdam and Kügler from the University of Frankfurt. Languages are rhythmic, and traditionally rhythm has been categorized into rhythmic classes, where we would differentiate between stress-timed languages, in which the basic rhythmic unit is the foot. Examples would be American English, German, and Dutch. Stress-timed languages, where the basic rhythmic unit is the syllable, examples being French, Spanish, and Italian. And mora-timed languages, where the basic rhythmic unit is the mora. For example, Japanese would be a mora-timed language. And there are several structural characteristics which indicate to you whether a language would fall into the one or the other rhythm class. Stress-timed languages classically display complex syllable structures with branching onsets and codas, and they allow for both full and reduced vowels, which are classically alternating. Syllable-timed languages, on the other hand, do not like complex syllable structures so much. They allow for them, but they would display fewer of them, and they only allow for full vowels. Mora-timed languages display generally very simple syllable types, CV predominantly, sometimes CVC, and they also only have full vowels. Modern analyses of rhythm since Dawa 83 have moved away from the idea that we really have these categories of rhythm classes, but they would suggest that we're dealing with continua of rhythms, so that it's a more gradient characteristic. Nonetheless, these labels, stress-timed, syllable-timed, and mora-timed, are still being used for understanding how languages pattern with each other. Evidence for the rhythm classes also comes from infants, where we could observe that newborns are able to discriminate between languages from different rhythm classes, so for example between stress-timed Russian and syllable-timed French, whereas newborns cannot discriminate between languages that fall into the same rhythm class, so for example syllable-timed Spanish and syllable-timed French. And in these studies with newborns, it doesn't matter whether you play them their native language or a non-native language, and it also doesn't matter whether you play them natural speech or low-pass filtered speech that only conveys the prosodic information, which really suggests that there are surface cues on the prosodic level that must provide information of the basic speech rhythm to these newborns that they are sensitive to. And these results from newborns have led researchers from the same group that performed these newborn studies to the hypothesis that there must be surface cues that the infant can track. And their hypothesis was that newborns would track low-level acoustic timing information in speech, in particular the durations of vocalic versus consonantal portions in languages that they listen to. To explore their hypothesis, they took 8 languages, measured the vocalic and consonantal intervals, and performed different measures to see whether the languages would be classified on the basis of these surface cues into the classical rhythm classes. And they found that a rhythm metric, including the %V, which was the proportion of vocalic interval durations, by delta C, which was the standard deviation of consonantal interval durations, would. Matisse et al. Then followed up on this work, suggesting that one would also have to take speech rate into account, as this is something that varies between languages but also between speakers. So they measured vocalic and consonantal intervals in 4 languages and came up with a rhythm metric that also included %V, so the proportion of vocalic interval durations, and additionally varco V, which controlled for speech rate. And it was calculated as the standard deviation of the vocalic intervals divided by mean vocalic duration multiplied by 100. And this metric clustered the language into distinct rhythm classes as we would know them from the literature. The goal of the present study is now to shed light on the question of how generalizable these surface-based rhythm metrics are, and our approach to this is to study languages that have been under-investigated in the past and that are typologically unrelated to the languages that have received attention in the prior literature. In our study, we apply Ramu et al.'s and Matisse et al.'s rhythm metrics, as they are the ones that are most widely applied. You should note that there are more studies that have suggested variants of rhythm metrics based on surface information, for example by Grabenloh, Prieto et al., and Arvaniti and Rodriguez, which, for time constraints, we have not included in our study, but we suggest that future studies should be doing that. We're now flying to Ghana, which is a West African country located by the coast. 50 languages or more are spoken here, and Ghanaians are usually multilingual and speak Ghanaian English, the language of education and official business, as well as additional local languages. The languages that we selected for the present study are the three that are most widely spoken in Ghana. The first is Akan, a Kwa language from the Niger-Congo language family that is spoken by between 8 and 10 million speakers in Ghana. And Akan has relatively simple syllable types, CV, C, and V, and sometimes you would observe CCV as a result of vowel reduction. Ewe is also a Kwa language from the Niger-Congo family, spoken by around 4 million speakers in the southeast of Ghana and Togo. And also Ewe has relatively simple syllable types, CV, CC, V, as well as V and nasal syllables. Both these languages, Akan and Ewe, are tonal languages. The third language we picked is Ghanaian English, an English variety originating from British English, a Germanic language from the Indo-European language family. The syllable structure of Ghanaian English is simpler than that of British English. Consonant clusters are typically reduced, syllable codas are dropped, and we observe that diphthongs are being monophthongized and length distinctions are neutralized. Based on these structural characteristics, we would predict for Akan and Ewe that they are syllable timed, as also suggested in a study on Akan by Olivo, or they could be mora timed, as most languages with lexical tone, as for example Nigerian languages investigated by Good and Milde in 2002. For Ghanaian English, our prediction would be that they might be more syllable timed than American English based on the fact that they have these reduced consonant clusters and neutralized length distinctions. In our study now, we included 4 native speakers of Akan and Ghanaian English and 2 native speakers of Ewe and Ghanaian English, and 1 speaker of Northern American English, who served as a control speaker to see how Ghanaian English would pattern with American English, a more well-studied case. As stimuli, we used 5 short declarative sentences that were then translated into the 3 languages. They were read by the native speakers of the languages. So English, for example, was read by old speakers. The sentences varied in length between 13 and 19 syllables. Speakers were instructed to read them as naturally as possible, and the recordings of the productions were performed in a sound-attenuated booth, except in 1 case. To pre-process the data, we segmented the speech files into consonant and vowel intervals, following Ramu et al. Using Pratt. And for the analysis, we calculated the durations of the vocalic and consonantal intervals per sentence. Silences were omitted, not included into the analysis. And for an illustration of a segmentation, we are showing here a sentence from Akan. For the data analysis, we calculated the percentage V and the delta C, following Ramu et al. And we also applied a percentage V and Varco V measure following Matisse et al. On this slide, I'm showing you the results applying the metric that Ramu et al. Suggested, percentage V by delta C being plotted on the y-axis and percentage V on the x-axis. Now in the figure, I will use circles to show which languages I'm speaking about. Whenever you see a dashed circle, this is showing data from Ramu et al.'s original study. The solid circles display the novel languages we have included in the current study. So let's start. We are now seeing Ghanaian English, which is located at the top left of this graph, which is very closely related to American English that we have collected for the present study. And these two languages do cluster most closely with the stress-timed languages that have been studied by Ramu et al. And they're quite distinct from their syllable-timed languages from this original paper, and also distinct from the Mora-timed language that Ramu et al. Included. So how about Akan and Ewe? They are clearly distinct. They're located at the top right of this plot. So they're not patterning with any of the previously described languages. Let's now see what happens if we apply the percentage V by Varkov measure that Matisse et al. Proposed. Again, dashed lines Matisse et al.'s data, and solid circles would be showing the novel data that we have included in the present study. So let's first find Ghanaian English. Ghanaian English is now at the bottom left of the graph, and this is distinct from American English, which is at the top left of the graph. American English clearly patterns with the stress-timed languages identified by Matisse et al. And it looks like Ghanaian English patterns more with the syllable-timed languages, French and Spanish, that Matisse et al. Have included. So how about the understudied languages? Akan and Ewe are more distinct from the languages that have been analyzed in the past. They are found on the lower right of the graph. So how can we interpret these results? Let's start with Ghanaian English. If we take the percentage V by delta C measure by Ramu et al., we would have to conclude that Ghanaian English is stress-timed just as American English. Whereas if we took Matisse et al.'s rhythm metric, the percentage V by Varkov, we would need to conclude that Ghanaian English is syllable-timed. And this is problematic. It indicates that the choice of rhythm metric impacts the interpretation. And this problem has already been pointed out in the past, that the surface-based rhythm metrics are inconsistent. So how do we now interpret the results of Akan and Ewe? Should we classify them as syllable-timed languages, or as Mora-timed, or as syllable-timed? And in order to help us interpret the results, I would like to draw your attention to the individual rhythm parameters that inform these rhythm metrics. Let's first look at delta C. So, delta C, if we would draw a line here between the languages that are classically assumed to be syllable-timed versus stress-timed, we would need to conclude that Akan and Ewe should be interpreted as stress-timed because they are located above a certain threshold where we would usually find stress-timed languages. However, if we took as a threshold the percentage V parameter, we would need to conclude that Akan and Ewe are both Mora-timed languages, because in this dichotomy they would pattern most with the Mora-timed language Japanese, for example. Now let's move over to the other plot, because there could also be an indication that both the languages are syllable-timed. If we now would take the Varkov as the parameter of choice for a threshold, we would have to conclude that both Akan and Ewe are most on par with the syllable-timed languages, French and Spanish here. So again, this suggests that the choice of the parameters impacts the interpretation. So, to conclude, it looks like Ghanaian English could either be like or unlike American English, depending on the rhythm metric that you apply. Akan and Ewe display rhythm profiles that are clearly super distinct from any other language we have considered in the literature so far. And these results again highlight the relevance for developing a generalizable rhythm metric that more languages will have to be considered. Something we would like to do in the future is to perform language discrimination experiments with young infants learning the studied languages in order to find out whether these infants would attend most to delta C, percentage V, or Varco V in order to discriminate between the languages they're learning. Thank you very much for your attention, and we are looking out to your comments and your feedback.